about transformation. You know, what does it mean to transform something? Is an English word. It usually goes together with vectors anyway, so sometimes you see vectors and transformation. That's why I started with vectors. So what does it mean to transform something? To change something, you know. So basically in geometry, transformation is to change the shape, either by making it larger or moving it, shifting it, or rotating it. So there are actually four basic things we look at in transformation. Translation, which is like a shift. To translate means to shift something. Are you getting that?
Yes.
There's translation, there's enlargement, which of course is making bigger or even smaller. When we look at enlargement in details, we recognize that enlargement can be making something bigger or even making it smaller. And then you have rotation, which is to turn it around, you know, at about 90 degrees or 270 or 180. And then we have, I mentioned translation, enlargement, rotation. Then there's mirror, reflection. Reflection is just to get an image of something. You know, like when you look at yourself in a mirror, your image is your reflection. There's another one which we call stretching or dilation. That is no longer in IGCSE syllabus, and most exam boards at A levels, so we won't bother ourselves with that. So let's go straight to translation. It's easy, really, really easy, and you will really enjoy it. I looked a little bit about this when I was looking at vectors, particularly column vectors. Look at this diagram here. It's actually a very interesting topic. Really very interesting.
And that's you have said about every single topic.
I'm telling you, it's exciting. You will love it. And just watch it. You will see how you will love this thing. Look at this shape. And we want to translate this shape. Translation simply means shift. Whenever we're talking about translation, we use two different things. How you want to move it horizontally and how you want to move it vertically. The upper one, the first one, so it's like a vector. You know, I told you all of these things are related. That's why I had to look at vector first.
No, I have a question.
Yes, go.
So after translation, what topic is next?
After transformation, the general topic itself is transformation. You know, it depends. It's your decision to know the next one. But you know, transformation is under shape, measures, and angles, geometry generally. You know, so of course we need to look at the other aspect of geometry like mensuration, perimeter, volume. We've looked at trigonometry, maybe sine rule and cosine rule, bearing. They are all under angle of elevation and deviation. We've done part of it. You will even find many of them in the previous lessons. All right, so this is generally transformation. So I was saying something about translation, which is the first one I'm going to start with. Like you can start with anyone, but I believe translation looks like the simplest. When you are translating, there are two things you must mention. How you are going to move it horizontally, which is represented by the upper number, and how you're going to move it vertically, which is represented by the lower number. So you translate something using a vector. Like in this case, vector 5, 2 simply means move it horizontally in 5 places and move it vertically in 2 places. Now if it is like this 5 is plus, right? It's plus 5 now. You are going to move it horizontally to the right. You know, yeah, that's it. Let me just show you. I remind you. I told you this is exciting. It's an interesting mathematics. You know your Cartesian plane. You know y, you have positive y up, negative y down. So if I have all y is about vertically. So if I'm moving vertically, positive like positive 5, I just move up. If I had -5, I would have moved down 5 places down.
Oh, yeah.
Now also for x, you have positive x and negative positive x to the right, negative x to the left, is it not?
No.
Negative x to the left. Sorry, that space is not enough for me to write it. Okay, but I think you understand what I mean. For horizontally, positive x to the right, negative x to the left. For vertically, positive y to the up, negative y down. So how are we moving this one? How are we moving this particular shape, object A? Then we are going to move it by the vector, or using the vector 5, 2. How are we going to move it now?
So I don't know.
No, based on what I said,
5 is
5 places,
Y
5 places to the right,
to the right.
horizontal, is it not?
Yes.
And you have mentioned the one for the horizontally. What about the 2?
To the left.
Uh-uh.
To the right.
I said the one down is about vertically.
Vertically.
So how are you going to move it with the 2? You move 2 places up. Can I say that again?
Yes. So 5 is going
Horizontally. And the first one mentioned up is about horizontal motion shifting. So we're going to shift it 5 places to the right.
to the right.
Yes.
Okay.
And then we also shift it 2 places down. 2 places up is positive 2. Vertically, the one mentioned, you better see it. The first one is x, the other one is y. Simple. Okay, so let's start. It's not difficult. You start from any point. You can start from A. Let's start from point A. How are we moving A again? 5 places to the right and 2 places up. So you move 1, 2, 3, 4, 5. It will show. Can I do that again? 1, 2, 3, 4, 5. That's 5 places to the right. You also move 1, 2 places up. And this will now be the new position of A.
21 and 2 places up? Okay, I've seen it.
Because the y is 2, the x is 5. So you start from any point, move it 1, 2, 3, 4, 5. That's 5 places.
So is it where the up stops?
Exactly, that you now do the new position of A.
So opposite this picture.
Yeah. That one is a different thing. That's reflection.
Okay.
The one you're talking about is the one below. It's reflection. We'll come to that. I'm still talking about. In fact, what I will do is to do translation on this one, or I will draw another one. So let's go again. Vector 5 2 means what? Remind me again. What does it means to translate it using the vector 5, column vector 5 2? What does it mean? 5 along the x-axis. That is 5 to the right now because it's a positive. And what? 5 places to the right, and mention the 2 now.
2y.
2 places y vertically. That's positive y. That's all. So that's what I'm moving. 1, 2, 3, 4, 5. Then 1, 2. This will be the new position of A. I take B again. 1, 2, 3, 4, 5. 1, 2. This is the new position of B. You do the same for C. 1, 2, 3, 4, 5. 1, 2. So you just joined. You have found a new position. Well, the test of the pudding is always in the eating. Let's since you want to get it immediately, let's try with one. Let's try with one example. Good. Draw the exactly. Let's use this one. So that past question, page 13 or 14. 13 or 14. You will understand it with this practice question. 13 or 14, that's where I am. What did he say? Read out AI on the right.
Draw the image of shape A after
Translation by the vector -5 -4. Beautiful.
That's the question. Oh.
This is where I am. Draw the image of the shape A after translation by the vector -5 -4. And you get your cool 2 marks. I told you this one is an all commerce affair. You just come here, get your 3 marks, 2 marks, sometimes 4, and you move on. Okay, that's vector A. So let's go. It says we should move it. So describe how we move it.
X is -5.
X is -5, which means what? What does it mean?
This side.
We move it to the left. How many places?
5.
5 places. So let's go. 1, 2. -5 is 5 places to the left. That's what it means. So let's count. So the best way to do this, I will advise you.
You count. -5 is just there.
You didn't hear me. Pay attention. -5 does not mean you take it to -5. You move it 5 places.
From where
it is.
Okay.
That's what it means. It didn't say go and drop it at -5. That number tells you how many places you're going to move it. Now the sign tells you which direction. The sign tells you that's minus, or plus tells you which direction. If it is minus, you are moving it to the left. If it is plus, you are moving it to the right. That's for X. If it is plus for Y, you're moving up. If it is minus for Y, you're moving it down. Because that is where you have the Cartesian plane. Plus and minus. This is plus of Y, minus of Y. Plus of X, minus of X. Okay. So, I was trying to tell you that the best way to do this is letter the edges. It's easier. The corners. Sorry, not the edges. Letter the corners. So I can call this one P, Q, R. Did you see that? So that I can start with 1. So let's start with P. Move P how many places to the right?
5.
To the left. 5. 1, 2, 3, 4, 5. You drop here. And then what did he say we should move again?
So it's not all on my screen.
It will show. I've moved it 5 places to the right. And then I have to move it 4 places how? Down. 1, 2, 3,
4.
1, 2, 3, then 4. So this is where the new position of P will be. This is where the new position of P will be, what we call P prime. You do same for R. Let's go for R.
Is that what you asked us?
That is all this is about. For the love of school. I just told you. That's all this is about. Yeah, it's as simple as that.
Why is there P, Q, and R?
Why is there one? No. So that it will help you to locate position. You know, I added the P, Q, and R myself.
Yeah, but in the question.
No, nobody is asking you to add it. If you listen to me, I said.
So we're only meant to find P.
You're only meant to take A to a new position. Take the whole of shape A.
Okay, but let's liberate this for us.
Just take position A to a new position. I added the point position corner this point PQR so that it will help you to move at least 1 point after another. So I've moved point P to a new position. Let's move R so that when I mention R, you know what I'm talking about. Let's move R. I'm going to use a yellow color. How are we moving R again? 5 places to the
back,
to the left, and 3 places down.
It's not 4 places.
4 places down. Sorry, 5 places towards left. 1, 2, 3, 4, 5. Right.
Yes.
Then 4 places down. Right.
Yes.
1, 2, 3, 4. Beautiful. So this is the new position of what?
R prime.
So as R prime. This is
So how are we going
mathematics for dummies. Everybody can get this.
So how are we not going to draw the triangle?
You just join them. That's why I added letters so that you can just join the points one after the other. See the positions I have. I have position P, R. I have position this. I'm going to join them. So why not get the one for Q before we continue? What color can I use for Q? Let me use black. 1, 2, 3, 4, 5 to the left, and then I do what? 1, 2, 3, 4 down. So this is the new position of P. Who cannot get this? Everybody can. So this is the new position of Q, sorry, which is Q prime. Just join the points and you are good to go. What color can I use now? I can use, let me use black again. So you just join the points. Just join P to Q, and then join P to R, and then join R to Q. Sorry, where did I dot? Okay, sorry, yeah, that's it. Remember, what I actually did here was Q prime. This is Q prime, just like this one is P prime, and this one is R prime. You have your answer. So you have translated A. We are good. See how easy this thing can be. I don't know, let me see if there's another question. You said draw the, we'll come to reflection, oh sorry, rotation. Let me see if I can find another question on translation. Sometimes they may do it for you and ask you to describe what happened. Look at this one. I love this. Go to page 12 or 14. This is an interesting math. You so enjoy this.
Which
Page 14, 12 or 14.
Yes, but like which one?
This the one on the right. Right again. Read out the question. Describe fully the transformation which maps shape P onto Q. I think we can zoom it out a bit. In a bit. Yeah. Describe fully the transformation which maps shape P onto Q. Shape P onto Q. What took P to where Q is? If you check, they look exactly the same and in the same orientation, so it has to be a shift, which is translation. Nothing turned, nothing got bigger.
Also, there's a translation.
But then you describe it fully for the love of school. You have to describe it fully. There are two things you need to describe a translation: a column vector. In other words, how it was moved horizontally and how it was moved vertically. So how do you think P was moved horizontally? And how was it moved vertically? It was moved to the left. Beautiful. How many places? So let's count. You can even letter the edges. You can call it P. Okay, you already have a P. So I can call it A, B, C, D. Check how A was moved. You just need one position to know. A was moved 1, 2, 3. Is it for his? Okay, no, it's not. I've not counted fully because this is the new position of A. I hope you know this is the new position of A prime. So let's count very well. Let's count very well again. 1, 2, 3, 4, 5. I think it's 5. 5 to the left. Am I right? I want to check again. 1, 2, 3, 4, 5 to the left. And then we know how it was moved up. Let's check how it was moved up. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. So what's the translation that mapped A to A prime? Yes, tell me. Describe it fully. So you mentioned the movement fully.
5/8. Minus 5/8. No, minus 5/8.
You are correct. That's minus. You see, and you've gathered your 2 marks. That's minus 5 because it moved 5 places to the right and to the left, isn't it? 1, 2, 3, 4, 5 to the left and 8 places up. Because it's the left, that's why you're saying minus 5. And because it is up, that's why you're just saying 8. So the answer is simply minus 5/8.
You leave me alone.
Please, no minus 5 over 8. So you say it is translated. You have to mention translation. Translated by a column vector, minus 5, 8. Or translated using a vector. You know it's a translation, it's just a shift.
Yeah.
Translation using vector minus 5, 8. You know, when I started and I told you that this thing is so easy, so interesting, you thought I was joking. This is how interesting maths can be. Once, see, you could have given up, and then you thought that's all there is. All right. Okay, so we've looked at translation. I think we can go to reflection. Reflection is what happens when you're looking at yourself in a mirror. You just see your image on the other side. You know, when you are reflected, the left hand side appears on the right, the right hand on the left. That's reflection, like what we call in physics lateral inversion. Yes, the nature of the image formed on a plane mirror is laterally inverted. If you remember your physics, same size, same distance from the mirror, same size. It's just that the left hand side appeared. Have you ever looked at yourself in the mirror? Do you look bigger in the mirror? A plane mirror I'm talking about. Yes or no? When you look to yourself in a plane mirror and you saw me, I know you will jump out of your room. That I even followed you to your mirror. Ha! This one is serious. So, if you look into the mirror, you see you, not me, not even your twin sister. Same size, same shape, and one important thing is same distance from the mirror. In reflection, we have what we call mirror line. I think I can zoom it in now. Remember, this first one is translation. I started with A, translation. This A is translation, which is like shifting. So I can just use the word shifting. Reflection is mirroring. So this second one is mirroring, B, reflection, which is mirroring. In reflection, you need to consider what we call the mirror line. That's all you need, the mirror line. Whether it is a vertical line or a horizontal line or a line somewhere, just the mirror line is all you need for reflection. It's the same shape now, so you're not going to talk about the fact that it is larger or bigger. It's the same person you are seeing in the mirror. So it's just the mirror line. Like this one. See the shape A, the main shape, and see the mirror, the image. Like what we call object and image. See the mirror line. What's the mirror line? I need to talk about this mirror line thing because you need to know it. Are you ready for that? Mm-hmm. All of this. In fact, reflection is even simpler than all the one I talked about. And it will interest you to know that they are so easy. Reflection is simpler. Look at this. Maths is a very interesting thing if you open your mind to it. In your next life, you'll be a professor of maths.
Very good.
In your next lifetime, if there is any. Unfortunately, there is none. There's only one life. So you have to live it well.
My next life.
The next life, you say your children will all know maths.
No, the next life, in this life.
In this life, I like that. That's the only life anyways. Look at this yellow line I just drew here. What's the equation of this line?
6.
On what position? When you are describing a point on a Cartesian plane, you need to measure whether it is on X or on Y. 6 on what?
5x.
6 on what? X. So this line is the line of equation X equal to 6. Did you see that?
Um,
This is a line of equation x equal to 6. Let me draw another line. That's the yellow line is x equal to 6. Let me draw another line. You tell me the equation of this line. This green line, what is the equation? Remember, you need to mention the 9 of what?
why?
Y. Is it a positive 9 or a negative 9?
-9.
So how should you define the equation? No, that's the negative. You remember I told you about Cartesian plane. Up is plus y, down is minus y. To the right is plus x. To the left is minus x. So this is below the x-axis. So it is minus of y. Up is plus of y. Hello? So what's this position? So how do you describe the equation?
Y equals to -9.
Y equal to minus 9. Simple. That's y equal to minus 9. Isn't it that easy? So that's y equal to minus 9. A line of y equal to minus 9. That's a green line. What about this one? If this is x equal to 6, what about this one? What is this line? This line I'm tracing. No. You see where it is. What position of x is it?
Eh?
What position of x is this one I'm drawing?
9.
So that you remember. You see it. This is 6. This is 5. This is 4. This is 3. This is 2. This is 1. What is this position on x?
0.
So, yes. So this line is what?
0.
Say the equation properly now.
Y equals to 0.
Huh? Remember all these things about x.
X is equals to 0.
So this is actually a line of x equal to 0. You better take note of this. This is a line of x equal to 0. This line. What about this one? If you understood that, what about this one now? This one.
Y equals to 0.
Y equal to 0. So this line is a line of y equal to 0.
So I actually not confused. Because y is this way. X is
I
this
like that. I wanted you to bring that up. Interesting. I like that. So this is x equal to 0. There's no confusion. I just want to use a different marker so that it will. Why this one is x y equal to 0. Watch this. Y equal to 0. Yes, watch it. The way to sit up. The way to get this thing right is check, like I started with x equal to 6, x equal to 5, x equal to 4, x equal to 3, x equal to 2, x equal to 1. So this has to be x equal to 0. In fact, the y-axis is a line of x equal to 0. That's a y-axis. So it's the same thing as a y-axis. Did you hear me?
Yes.
So y-axis is actually the line of x equal to 0.
But this is not what you told somebody.
The y-axis itself, I'm talking about the y-axis itself, is the line of x equal to 0. Now check this again. See where I'm tracing. What is this line? Can you mention it?
Y is equals to 4.
Y equal to 4. This one is y equal to 2. This is y equal to 1. So this has to be y equal to 0. So the x-axis is actually a line of y equal to 0. So this is the x-axis. So if that is the case, what is the mirror line of these two shapes? The object in pink and the image in green. Anyone can be it's the object is actually the one in green. The image is the one in pink. The image is the one you see prime. But it doesn't really matter. The object is the one in green. The image is the one in pink. What is the mirror line? The mirror line is what separates them. What's the mirror line? Tell me.
What separates them?
What's this mirror line?
X is equals to 0.
Is this a line of x equal to 0?
I can't even tell you.
You can see it now. Even if you didn't see it at your end, you should know. Let me trace it again. You're back. You can see it now.
Yes.
What's this line that separates them?
Y equals to 0.
It's the line of y equal to 0, which is the x-axis. So that's the mirror line. So you can simply say reflection of this on a mirror line which is y equal to 0. That's how to describe it. So this shape, the original shape ABC is reflected by this mirror line y equal to 0. Let's check this one. In fact, during reflection, all you need to do is, I will even tell you how to do it. I will use one of the questions. During reflection, you just start from a point and begin to draw lines. Okay, hold on, let me draw this so that we can understand better. Let me get this. I can even use this to illustrate it. I will use this to illustrate it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 on x-axis. Then of course minus x. You have minus 1, minus 2, minus 3, minus 4. Then you have 1, 2, 3, 4, and so on, 5, 6. What is this shape? What's the mirror line, first of all? This particular one. This is the original thing. This is the original thing.
So when is that on the dotted line?
Pardon?
The dotted line.
The dotted line is the mirror line, and that's the one in between them. That's correct. That's the dotted line. So what's the equation of this mirror line?
X is equal to 2.
Beautiful. Say it properly. X equal to 2. You're right. So this mirror line is the mirror line. Mirror line is x equal to 2, which of course this dotted line. This dotted line is a mirror line, which is x equal to 2. Okay? So it means this shape is reflected by this mirror line, x equal to 2. Okay? So let me just write it in full. So this is reflection. This one is reflection about mirror line.
What's my phone?
Mirror line. About mirror line. X equal to 2. Reflection about this mirror line, x equal to 2. X equal to 2. Don't forget, you just need to know the particular line that divides the two shapes into two equal parts. That is the mirror line. And the mirror line for this particular one, this is the original object, and this is the image. So it's a reflection about mirror line, x equal to 2. That's how to describe the transformation. You know, so in describing transformation, all you need is the mirror line. Just mention the mirror line. In describing transformation, you mention the mirror line. In describing translation, you need to talk about the translation vector, like 5, 2 in this case, and the other ones we worked on. That's how simple this thing can be. Of course, we'll be looking at enlargement and rotation after this. I think it's getting clearer. Is it? I didn't get your response.
Yes.